My conclusion is, my conclusion is, my conclusion is.
Just checking the very complicated algorithm that helps Florence decide whether it is or isn't time for tea. We're checking it's working properly. And I think it is. That's great.
My conclusion is, my conclusion is, my conclusion is.
All a little bit disturbing.
My conclusion.
Heinous sin, I hear you cry. He soldered a piece of wire across the fuse holder and dispensed with the fuse. Crazy. Well, having started off with a rather unnatural attraction to fuses and sprinkled them around like there's no tomorrow, I discovered, with common sense really, that they are actually like small resistors, especially the low current fuses. A fuse of, say, sort of 200 milliamps has got quite a high resistance, it has to have, otherwise it will never melt. So you need resistance so the electricity flowing through it creates heat and can melt it if it gets too much. But that means you end up with a circuit with all sorts of unwanted resistances in the power lines. I discovered there was quite a voltage drop across the 2.5 amp fuse that I used originally in here, and that was causing everything to drop and flicker when the sound got too loud or when the flickering lamp was working. So I ended up getting rid of it. The fact is, if you use these switch mode power supplies, they have over and under voltage and current protection anyway, so they're pretty rugged and safe. Even the signs take a long time to design. A lot of effort goes into what to say and how exactly to arrange it so that it looks right. I've printed off a test version of the top one because it's quite a big thing and I want to check that it looks right before I go ahead and engrave it from the proper plastic. I'm really happy with that. I think that looks great. So I'll get all the signs engraved and then fix them on. Brilliant. This is definitely the biggest sign I've ever engraved. It's huge. I thought I'd do it all properly with the raster engraving to get really good quality. So let's get it on the machine and get it going. This engraving laminate is a layer of black plastic at the back, about 1.5mm thick, with a very thin layer of white plastic on the front. So once the laser starts cutting away at it, taking a titchy, really shallow cut, you see the black coming through from underneath. Because the honeycomb part of the laser cutting bed, this bit, is quite small, the engraving plastic laminate is too big and it's not sitting flat properly, and because the focus is so critical, I'm going to rest this on the top. You can buy larger perforated screens, but they cost a fortune. I discovered this, and this is ventilating mesh. You get it from ventilation companies, and it's perfect. It supports it, it lets the fumes be drawn through, it doesn't provide too big an area for the laser to reflect off, and it really is very, very stable, which is great. So that's what I'm using. That's much better. I now know that that's completely level and that the laser will remain focused for the whole job. Because raster engraving is such a slow process, I'm not going to bother to film this. I'm going to go and make myself a nice sandwich. Starting to feel a bit of trepidation as I'm coming to the end of building Florence, as I've been doing it for about 3 or 4 months. So, last few jobs. The engravings have come out, and as you can see, there's lots of soot around them. When you cut acrylic, you don't get any soot, it just melts through. Get a slight smell. But this engraving laminate must be made of something else, because it burns slightly differently, it cuts, and you do get this soot. This is good quality laminate, and I can quickly get the soot off with some rubbing alcohol. I have tried using cheaper laminate, and it's awful. You get so much soot that by the time you've cleaned it off, you've actually worn away the white layer, and it's just useless, fit for nothing. But this does produce a very good finish. Right, I think that's fine. Simple as that. Excellent. yeah, I'm very pleased with that. I think that looks great. And it just lines up nicely with the control knob, makes it quite clear what you're meant to do. It's a bit like a fairground machine in a way, so it's, you know, it's important that the instructions are very clear and large. I also like the way that the instructions are white and Florence's head is white. There are a lot of the knobs white, and obviously there's going to be the top bit. Talking of the top bit, I'm very pleased with how it's come out. It was one of those signs that took ages to design to try and figure out the shape that would look right. So it's going to be mounted somewhere like that on the top. I need to work out how to fix it down, as this is the last bit of work that I'm going to have to do on Florence, which he's a bit apprehensive about. I thought what I could do is to make the post give me one last chance, well, a chance for now anyway, to machine it out of some hexagonal brass rod. Then it can screw to that, that can screw down, and also then on the top of the brass rod, the Victorians decorated everything they possibly could to demonstrate the amazing engineering abilities that they had. So I might screw that onto the very top either side. Why not? Lovely. Another major design decision with the main label. Should it be flush with the top of the hexagonal rod, or should it just show a little bit with the ball on top? Oh, decisions, decisions. I'm not saying this is cramped, but this is cramped. I've even had to move a box that's sitting on against the end of the lathe so I can get the rod in. So here's the, I think it's 12mm face to face or something. I can't even fit the rod. Here we are. Right, I've worked out how long I need each piece to be. So the first thing to do is to chop them off to the right length, 2 of them, one for each end. Just got to move these bits of wood. Stuff everywhere. My brand new tidying up regime hasn't quite made it over to this side of the room. Okay, let's get a ruler. That says 50, oh, very accurate here with a bit of pencil scribble on it. Oh, I'll call it 51. Okay, I've got the parting off tool in the tool holder, and it looks roughly vaguely parallel. Apologies for the quality of machining in this place. Right, I've got my goggles on, the chuck's not in. Always the thing with lathes, never leave the chuck in the chuck and switch it on, because this will fly around and hurtle off and embed it in a head or wall or something. Oh, actually on the floor. That one will probably do. Again, it's not the right one. Oh, I messed up. That's not bad, actually. Here's the one end of the piece of brass I've cut off. The lovely rounded ends. If I show you what I mean, yeah, look, that lovely pattern you get just by putting a slight angle on it. Angle the dangle. Now, what I've got to do is fix the ball on one end, that in the middle, and then this needs to screw through the top of Florence's cabinet, 3mm ply. I thought I could cheat and just drill a 5mm hole through the middle, but the longest M5 screws I've got are just too short. So what I think I'm going to do, any excuse to prolong the agony, is to drill and tap a 5mm hole in the top M5 and use one of these little bits of M5 studding I've got, which is basically just like a bolt or a machine screw but without a top on it, and there's another bit which I use at the bottom, and then I can just put a nut underneath up into it to tighten it down to the top of Florence's cabinet. Then drill 2 little holes there and tap them out to M3 so I can screw into them. And I'm going to use my RS Pro M5 tap and 4.2mm drill. How exciting! What could go wrong? Before you drill with a normal drill bit into the end of something that's in the lathe, you use a centre drill, which is basically a very, very thick drill bit that doesn't wobble around. Bring that up, we'll clamp everything down so it can't wobble around. Switch it on. 4.2mm, because when you tap out to 5 M5 you want the original hole to be slightly smaller. If you drilled it out to 5 then you wouldn't be able to have any metal left to tap into. I have put the tap, the M5 tap, into the drill chuck on the lathe because it just helps to line it up nicely, and it is really a lot easier doing it like this than doing it with a tap wrench. You know it's going to go in absolutely perfectly, and you go round a bit and then back a little bit to clear all the swarf, all the cuttings. Right, and then if you remember to put it the right way, you can use the lathe just to get the tool out. If you switch the switch the wrong way, then it just gets pulled in, smashes, breaks the tap, and you've ruined your piece of work and everything else. There we are. So what we end up with is a rather pleasant tapped hole in both ends. Right, I've done that one. Now I will do this one. Right, so we've drilled them out, tapped the holes in each end. Now you can see, if I get this little bit of studding, M5, that will screw in there, a bit tight, never mind. Once that's screwed in there, the little brass ball, which is also M5, will screw on the end. I'll have that flush so it doesn't stick up at all, but that should look really nice. Now the next job is, without scratching the sign up too much, need to work out how to fix this onto that. And what I'm going to do, measuring both ends the same height, I'm going to mark where the centres of the holes are and then drill them out to, I think it's 2 point something or other millimetres, and then tap them to M3. And I can put some nice little brass screws in there. Let's get that done. What a fabulous Christmas present. The gift that keeps on giving. Super glue is not just for Christmas. Right. This is a much better packaged super glue rather than those little ones I've used in the past. This one doesn't seem to stick closed, and it also comes ready punctured. What I'm going to do, originally, like I said, I was going to use these this M5 studs, but they don't go into the balls enough, and so much of it goes down in the top of this bit that, let me zoom in a bit, so much of it goes down into the top of this. I think with my M3 screws that are going to screw onto the front of this, they're going to go right through this and want to have a bit more space, a bit more depth, so it's useful having that hole inside. To cut a long story short, I've just sawn up an M5 bolt to just get two very short bits, about a centimetre long, which I haven't rounded the ends off properly, but there you go. Right, so tighten that, so we end up just enough to go into the little ball, and you probably can see that, the fact that that's still not far enough in to block that hole. So let's put the ball on the top, like that. Now the thing is, I just love super glue. I mean, it's not necessary to have any super glue on this, but paranoid android, why not use a bit of super glue, and then that will hold that tight, because yeah, it's really likely to wobble off or something. Never mind. That looks rather pleasant, even though I say so myself. Let's do the other one. Then we'll screw. Oh, come on, that's it. Oh, it's a bit loose. Super glue, possibly. Well, yes, actually. Yes, it's a little bit. And I can stick my fingers to it, so I'll in there. Get the hey, get the ball. That's it. Try that. Lovely. Now the next thing that requires a little bit of thought is I'm going to screw this onto these two, and then somehow I need to work out where to drill the holes for this. Actually, that's really quite easy. If I screw these onto that, all I need to do is get a ruler and measure the distance between the centres, and then I can just project it on. I'm going to use these little M3 screws. In fact, I'll push the boat out and drill them out to 3.5. Because what's 1/2 mil between friends? That means that there is a little bit of give and take. I'll zoom in a bit. That means there is a bit of give and take. And it is important to have that, because however careful you are, or not as the case may be, things don't line up and you need a little bit of wiggle room. Let's see. Right, there's that one. I'm not going to tighten them too tightly yet. I just want them to go in loose so that I can make sure that the two posts are vertical. So that's nice, and you can see, if I hold that somehow, yeah, you can see there's a few degrees of wiggle there. Let's do the other end. Yeah, that's fine. Now what I can do, rest that down there and measure extremely precisely 280, 282.5. That's good, it clears the bit underneath. Now I just need to spend another couple of hours torturing myself about where to position this. Well, I've got them marked out and drilled. I've got M5 machine screws and nice big washers just to reinforce, stop it tending to twist. So we end up with that, and then that will screw into that bit there, and hopefully in the right place. Well, I'll get that screwed together and we'll have a look. That's perfect, it's not bending, it's really quite rigid now because it's slightly in tension, and I am thrilled with that. I am very, very pleased with that. I think that looks great. It just reminds you of what it is. I mean, that's what it's all about. It's to answer that impossible question. Is it time for tea? Fantastic. So now I've got that one on the top, and the labels to make it work down there. Oh dear, I have a horrible suspicion that Florence and the Is It Time for Tea machine is actually finished. Oh no, what am I going to do now? Well, I've got a lot of things I can do now. Next thing is to put her in her travel box. Thanks very much for watching. I hope you enjoyed it and found it interesting. Please remember that we're going to be at the Whitby Steampunk Festival the weekend of the 8th and 9th of February. You can come along and see all the machines working for real, and also meet Florence for the very first time. How exciting. I also have a website, steamhead.co.uk, where you can find out more about all the machines and the background information, and a YouTube channel where you can see making of videos of all the different things that I've made, just like this one, and an online shop on the website, and an Etsy shop as well.